In the last video, we started on the inheritance challenge. In this video, we're going to go ahead and we're going to complete my version of the challenge solution. So moving on now from the Outlander class that we've created. Now what we're going to do is we're going to change a few things here. Because we've passed Volks as the type of gearbox, what that means is we've decided on an automatic transmission. And we're going to create a new method, which we call accelerate, which we pass a parameter of the speed, and based on that, depending on the speed that the car is traveling at, we're automatically going to change the gear because of course it is an automatic gearbox, and then we're obviously going to set the velocity and the direction as well. So to do that, we're going to create a new method, call it public void accelerate. I'm going to pass something called the rate. Now the rate is the difference in speed from the current speed. So what we're going to determine then is we're going to look at the new velocity of the vehicle, or the car in this case, which will be the new velocity equals, we're going to get the current velocity of the vehicle, which is the field essentially that comes right back from the vehicle class. Then we're going to add to that the current rate, bearing in mind that the rate can be a positive number or a negative number. So a positive number would be you've put your foot down on the accelerator, you've increased the speed, and a minus number would mean that you're de-accelerating, for want of a better term. But we're handling all of this in the one method. So the new velocity is going to be the new velocity of the car, taking into account the change that has happened or has been passed to this method. And so if new velocity is equal to 0, we're going to call the stop method. Otherwise, we're going to put else if new velocity is greater than 0 and new velocity is less than or equal to 10, then we're going to change the gear, because bearing in mind this is an automatic transmission. And we'll just do a few more. We won't go through and do all 6 gears, but we'll put if new velocity is greater than 10 and new velocity is, say it's less than or equal to 20, this could be miles or kilometers per hour, change gear 2. So we're getting the car to automatically change based on the velocity. If new velocity is less than or equal to 30, you can see what we're doing here, change gear 3. And for simplicity, even though I said there's a 6-speed, I'm going to put else change gear 4. So normally you would go through and you'd actually do the other parameters for the speeds. So what we're doing here is we've created a new method called accelerate, and depending on what the new speed is going to be, we're automatically changing to the relevant gear, which of course is what a car does automatically. It knows to change gear based on a certain amount of speed or revs. Then the last thing we need to do is we need to just do a final test. If new velocity is greater than 0, we want to change velocity, we want to call the change velocity to what the new velocity is going to be, and we also want to use get the current direction. So we're still going to go in the same direction. All we're doing is we're increasing or decreasing the speed. So that's now a method, as you can see, that's specific to the Outlander, but then it's changing gears. And of course the changing gear is based now on the method that we've defined in the car. And of course, some of the other features we're using, the stop method at the moment, we haven't implemented the stop method in here. We've only implemented the stop method down here. So what we really should do is with the stop method, so we could create a stop method and put it in here under the car to set the gearbox to the first gear, in other words, if the car is stopped. But that wouldn't be appropriate because we've decided that we've got a Boolean here for is it manual. So if it's manual, that's a manual operation to change the gear. But in the case of the Outlander, we defined that as to be using an automatic gearbox. So therefore we need to add the functionality to change the gear if it's stopped here in the Outlander and not in the car class. So we're going to put change gear 1. So in other words, if the car's stopped, it's going to automatically change the gear for us to first gear. So that's a very basic solution, as you can see, that we've come up with now. We've now got 3 classes. We've got the vehicle class, which is the base class, the base vehicle class. We used the car class to extend from that, and we added these parameters that are unique for a vehicle: wheels, doors, gears, and as to whether the gearbox was manual or automatic, and also the current gear. We're keeping track of what the current gear is for the car. And for the Outlander, of course, we're using that. We've extended from the car. The only real difference is we've added one field here, which is the number of road service months that come with the new car. And we've also added our own accelerate method, which is unique to the Outlander because it's an automatic car, or because it has an automatic gearbox. Depending on the gear and the speed that we're going to be going, we change the gearbox automatically. So let's try running this now and see what it looks like. So I'm going to create Outlander. Outlander equals new Outlander. And of course the parameters were just the number of roadside service months. So we'll say 36 for 3 years. And now what we can do is we can type Outlander dot accelerate. So let's accelerate, say, to 30 and see what happens. So let's run that. Let's make a bit of space here so we can see what we're doing. I'll just run it again. So you can see what's happened is we've defined a new object for the Outlander class, from the Outlander class, and we've decided to accelerate to 30. So the first thing that happened was we set the current gear. The gear changed to 3. Vehicle.move was called to be moving at 30 in the direction, and direction is 0 because we haven't defined a direction. Car change velocity was also executed. This is where the outputs can be a little bit confusing, because if we have a look at the code that was executed, we can look at our Outlander. It actually met this condition here because the speed that we've selected is greater than 20 and less than or equal to 30. We change gear to 3, but then we change velocity. And of course, change velocity is in our car class. We use the method called change velocity. I guess what we probably should have done there to make it a little bit better to read is we should have outputted that line first, like so, and then it'll actually appear in the right order. So we'll do that. So now it's actually set in the right order. So it shows the first thing that happened was the gear change was changed to 3rd gear. The car changed velocity to 30, and then it called the actual move method itself was called from the base class, base vehicle, based on this change velocity method, which called the base method from the vehicle. And we could change this a little bit. We could go back to our main class and we could maybe Outlander.accelerate just to see that it's working. We add another 20. So that should accumulate to be a total of 50 that we're going at. So if we run that, you can see now that what happened the second time after the second call changed to 4th gear, because that was our, if you recall, that was our else. We're only handling 4 gears in this scenario. The velocity was actually changed to 50 because we added 20 with the second call, added another 20. It's maintaining the current velocity so it knows that the current speed now is 50. So what we could probably have done also is just to make things a little bit clearer, is we perhaps could have started here and we could have put Outlander.steer, and we could say we're going to go at 45 degrees. And remember, the steer method is coming all the way, not from here, but coming all the way from vehicle, because we haven't overridden this method in the car class or the Outlander class. So if we run that now, vehicle.steer, you notice now that the vehicle.steer is now steering at 45 degrees. Car changed to 3rd gear and everything else is as it was before. The only thing different now is the direction. And the other thing, as I mentioned with the accelerate, I can also pass a negative number. So we're currently doing 50, Outlander.accelerate. Let's put minus 42 and see what happens. That should take us to 8, which should probably be 1st gear. Let's try that. So again, you can see what's happened was we changed down to 1st gear because the speed is now 8 and we're still moving in the same direction. So you can see how useful inheritance is, and it really gives you lots of flexibility to model real life objects in software. And as you can see, it's also very powerful and actually saves you a lot of coding. You're not having to create the code. So you can create the code for vehicle, in this case, and car once, and then for other types of cars, for example, a Porsche, it's very simple to create a new class and extend the car class. You've got all this base functionality built in. Now what you could have done, because what we've done with this accelerate here, we've effectively implemented a method to change gears automatically based on the speed. So we could even have created another class or added that elsewhere so that functionality was available for all cars that were automatic. So there's lots of flexibility, as you can see there. So I hope that's helped a lot. That's inheritance, and you'll understand more of this the more you use it, and it'll become a lot more familiar. So in the next video, we're going to start work on composition. Composition is something that can be used in place or with inheritance, and you'll see that there's many benefits to be using composition, but we'll start that in the next video.